And then they said how many lone pairs of electrons can be formed in the Lewis structure of ammonia. How many lone pairs of electrons can be formed? Let's break this down. We have nitrogen, hydrogen, hydrogen, and hydrogen. The total number of electrons here, total number of electrons here is nitrogen will have its element number 7 in the periodic table, and then the valence electron is 5 for nitrogen. Of course, for hydrogen is 1. For this one is 1, just 1 times 3 for hydrogen. So 3 plus 5, that's 8 electrons in total, 8 valence electrons in total. But the question is asking for lone pair of electrons. Remember, we have to do the first step. Nitrogen will be at the center. So we have nitrogen, hydrogen, and hydrogen. So out of these 8 electrons, how many are used to make bonds already? 1, 2, 3, 4, 5, 6. 6 are used to make bond. Total 8 electrons, 6 used to make bond. How many do we have left? 2 electrons. The 2 that we have left are going to be used for as lone pair of electrons. So the answer here is number 3, which is 2. So let's move on. So here we're asked to draw the Lewis structure for this element, for this compound, CO2, just like what we did for water last time. So we have oxygen, carbon, and 2 oxygen atoms. For carbon, the valence electrons for carbon are 4, remember? Carbon is element number 6 in the periodic table. It's going to be 2, 4. So 4 valence electrons. And for oxygen, we just did it now. The valence electrons for oxygen is 6 because it's element number 8. It has 6 valence electrons. So 6 valence electrons for this. And then there are 2 of them, remember? So it means it's going to be 2 times 6. So which is 12. 12 plus 2, actually 12 plus 4, that is 16. So the total number of 16 electrons are expected here. Again, carbon will have 4 valence electrons. One oxygen has 6. The other oxygen will have 6. 6 plus 6, 6 plus 4, that's 10. Plus 6, that's 16 electrons. And then the least electronegative here is carbon. So carbon will be at the center. So carbon is going to be at the center. So let's move here. If we want to draw this skeletal structure, we are going to have carbon. So we have carbon bond to oxygen and then bond to this oxygen. So we are done with the skeletal structure of carbon dioxide. So I want to redraw it here quickly. This is the skeletal structure. And then count the number of electrons used in the bonds. We use only 1, 2, 3, 4 electrons out of 16 electrons. Only 4 electrons are used. So we subtract 4 from 16. We will have 12 left. So we have 12 electrons left. So 12 electrons remains to be used. So let's go back. And then place electrons on terminal atoms to fill the octet. So octet for oxygen is not fully filled yet. You know, it's supposed to be surrounded with 8 electrons. It is only surrounded with 2 electrons, the one that is used to bond with hydrogen. So we need to provide the remaining 6 electrons on this. So by doing that, there is octet for oxygen now. Again, this is octet for oxygen. 2 electrons, 6 electrons, making 8 electrons for this oxygen atom. So we're going to do the same thing for the other oxygen atom. So that is what we are asked to do. Remember, we have, I think we have 12 electrons left, right? Yeah, And out of those 12 electrons, we have used how many? I think we've used all the 12 electrons already. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So all the 12 electrons are used already. Okay. And then place remaining electrons on the central atom to fill its octets. So we don't have any electron remain. There's no electron remain to fill the octet for the central atom. Control, copy. So let's move to the next slide here. There's no electron left for this. And then so let's just go on. Check that each atom has enough electrons around it. So do they have enough electrons around it? For oxygen, yes, it has enough around it. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 7, 8 for around the atoms of oxygen. But for carbon, we have only 1, 2, 3, 4. Only 4 around it. It's supposed to be 8, as we are saying now. So it's not this. The octet of carbon is not satisfied yet. It's supposed to be 8. So carbon does not have enough electrons around it. So let's go. So the next is to move electrons from terminal atoms to form double bonds so that all atoms they have 8 electrons around them, as we are saying now. So it means we have to move electron from here to form double bonds. So how do we do that? So it's like this. Let me just do it. You'll see it physically. So 2 electrons here. Let's move these 2 electrons to become double bond here. And then I'll move these 2 electrons as well to become double bond here. Can you see what we did now? So we can now delete, we can change those electrons to a bond. So we have a single bond, and then let me draw the bond. 2 electron becomes a bond, and then a total of double bond now here. So let's do the same thing at the other side. These 2 electrons, they become a bond. Remember, 2 electron is a single bond. So we'll put the electron here as well. So we have fulfilled what we are asked to do here. Move electrons from terminal atoms to form double bond so that all atoms have 8 electrons. So let's see whether all atoms, whether they have 8 electrons. So let's count for this oxygen. For this oxygen, how many electrons? 1, 2, 3, 4, 5, 6 for this bond, 7, 8 for the second bond. So it means that oxygen has the satisfied number of electrons. So let's do the same thing for this oxygen atom. So for this oxygen atom, we have this double bond means 4 electrons, and then we have 2 dots, 2 lone pairs of electrons, which is 4 as well. So 4 plus 4, that's 8 for that oxygen. What about the carbon at the center? We have to count the bond for all of them. The bond that link, then we have to count it for them. So we counted these 2 bonds, double bond for this oxygen. We are counting it for carbon as well, because it's between carbon and oxygen. We did the same thing for the other oxygen here. So we are going to count all the bonds for carbon because it is the central atom. So count it. 1, 2 here, double bond, that is 4 electrons, double bond here, that is 4 electrons. So we have 8 electrons around the carbon atom as well. So it means all of them, they have 8 electrons around them. All of them, they have been satisfied with their octet electron configuration. So what's the last point over there? So it means we are done. These are all the points, and this is the Lewis structure for carbon dioxide. Yeah, this is summary again. Valence electrons, skeletal structure, see how many electrons you have left, lone pair on terminal atoms for octet, check each atom, then make double bonds if needed. We did everything now, and then everything is fine.